Now that we have finished the algorithm and pseudocode for merging of two sorted arrays effectively, let's quickly write the C++ implementation of it, and later on let's move on to the implementation of merge sorting algorithm, in which we will be reusing this merging of two sorted arrays. So for implementing that, inside this sorting folder whatever I have created, here I'm adding one more file called merging two sorted arrays.cpp. Okay, so let me just minimize the side navigation. Here let me just import C++ boilerplate. Okay, now here, just like any other implementation that we are doing, let's just create a class merge to sorted arrays. Okay, here let's just add public method, which will basically take two sorted arrays. In the end it will try to return the resulting array in which all the elements are again arranged in the ascending order, assuming that we are getting both array1 and array2 are arranged in the ascending order. Okay, since we are using arrays, I want to make use of vectors here. That's why I'm also including the vector here. Okay, once we have added that, let me just put a semicolon here to close the class as well. In the end, as part of the function definition, in the end we will be returning the merged array, right? So let's just name the function as merge to sorted arrays, and this function will basically take two arrays of type vector of type int. Let's just say they are a1 and a2. Okay, once again I'm mentioning this a1 and a2 are the integer arrays in which both the arrays are sorted in the ascending order. As a result, once we merge these two arrays into a resulting array, the resulting array also, all the values should be arranged in the ascending order only. Okay, so that is an important thing that you need to remember. Now, using the pseudocode that we have discussed previously, let's just proceed with the implementation of this function. First, let's read the lengths of array1 and array2 so that we can reuse those variables later on in the implementation. So I'm just defining a variable length of a1. This will be a1 dot size. Similarly, I'm just copy pasting the same variable once again. I want to get the length of a2 as well, so I just made the appropriate changes in the pasted statement. Now similarly, I want to take couple of the helper variables. I'm initializing it with 0. Similarly, I will define one more variable j. This also I'm initializing it with 0. So this I variable basically tells us what index of array1 is currently being processed. Similarly, j variable will tell us which index of a2 is currently processed from the a2 array. Okay, now we have created the helper variables, right? Now ultimately what we need to do, we need to merge these array1 and array2 into another resulting array, right? That resulting array size will be equal to the size of a1 plus size of a2. For that, what I will do is, let me just define another vector of type int. Let's just say this is result. This will be of size length of a1 plus length of a2, right? Which we already have in couple of variables, length of a1 and length of a2. And in the beginning, I want all these values to be filled with 0. Okay, that's the reason why I'm just passing 0 as a second argument, so that all the positions of the current list will be filled with 0. Okay, similarly, when we implement the logic in the later steps, we will basically need a current index that we are currently filling in the result array. For that, let me just define one more variable, current index. This also we need to start from 0th index, because we will fill the very first element, which is nothing but 0th index in the resulting array. And likewise, as we put more and more values into the resulting array, we will keep incrementing this current index variable. Okay, now let's get on to the main implementation. We will be running a loop as long as there are unprocessed elements on both array1 and array2. What we need to do, we need to compare the values from array1 and array2, and appropriate value needs to be pushed into the resulting array. So that condition is nothing but as long as the current index I, which tells us the what index element is currently being processed from A1, if this I is less than length of array 1, that means there are still unprocessed elements in the array 1. Along with that, j should also be less than length of array 2. That means that there are still uncompared values from array 1 and array 2. Now we need to compare these two values. So if at all the element at ith index from array 1, if it is greater than the value at the jth index from array 2, that means that the smaller value is on the array 2, right? So that smaller value needs to be pushed into the resulting array. Okay, remember this comparison is very important. If you observe here, the value at ith index from array 1 is greater than the value at jth index from array 2. That means the second array has the smaller value. Since the arrays that we have got are arranged in the ascending order, the same ascending order needs to be followed in the resulting array as well. So we need to arrange the values from smaller to larger. That's the reason why I'm picking up the smaller value here. Now, what element needs to be filled in the result array? Whatever the current index element needs to be filled. So result of the current index equal to A2 of j. Okay, so we have successfully moved the element from jth index to the resulting array. So j, the next element needs to be compared and moved into the resulting array if required. That's the reason why here, to move on to the next element of the second array, I will increment the j by 1. Similarly, since the current index has been filled successfully, the next index needs to be filled in the later iterations. That's the reason why I will simply increment the current index also by 1. Okay. This is the case if the second array, array 2, has the smaller value. If this is not the case, that means that smaller value is there on the array 1. So we need to pick that value and we need to move it onto the resulting array. That's the reason why result of current index equal to A1 of I. Okay, since we have moved the element at ith index into the resulting array, we need to move on to the next element in the array 1. To move on to the next element, I'll simply increment I by 1, and since we have already filled the current index with the value from the array 1, we need to increment the current index also by 1 so that the next index gets filled with appropriate value in the later iterations. Now, this logic will basically run as long as there are some uncompared values in both array 1 and array 2, because the condition that we have put here is I is less than length of array 1 and j is length of array 2. So if at all, if the both arrays, whatever we are getting in the functional arguments, if they have the same length, this logic itself is enough for merging the entire sorted array. But what if the length of array 1 and array 2 are not equal? Then there is a very good chance that either in the array 1 or in the array 2 there are some unprocessed elements still left over. Now we need to move those values into the resulting array as well. So that condition is nothing but, now we need to run a loop. If at all the value of I is less than length of array 1, that means there are still unprocessed values from the array 1. So array 2 processing is completely done, but the only leftover values are there in array 1 only, because the length of the array 1 is greater than length of array 2. In that case, we will see this scenario. So in this case, what we will do, there are no more elements needs to be compared, right? So ultimately all the values are obviously greater than whatever we have in the last element of the resulting array. As a result, one by one we can simply move them onto the resulting array. So how will we do that? Result of the current index equal to A1 of I. Since we have moved the ith element, we need to increment I by 1, and current index has been filled, right? So we will simply increment the current index also by 1. Okay, so this is the case where there are unprocessed elements on the array 1. What if there are unprocessed elements on the array too, right? That's the reason why we will simply do, while I is, sorry, for the second array we are using the variable j, right? If j is less than length of array 2, then what we need to do, we just need to take the element from the array 2 and move it onto the resulting array. So a2 of j. Okay, here since we have moved the element at jth index, we need to increment the j by 1. Okay, and again current index should also be incremented by 1 so that the next positions will basically get filled with the values from the array 2. Okay, now there are no more elements that are left in either on array 1 or on array 2. So we have successfully processed all the values and all the values have been moved to this result array. Now we can simply return this result in the end. Return result. Okay, so that's all the implementation is. Very simple. We need to take the couple of helper variables which will tell us what position of array 1 and array 2 are being compared. As long as there are some uncompared values, we will simply run the loop and compare the two values from array 1 and array 2. Appropriate value will be moved to the resulting array. If there are some unprocessed values, we will simply run an individual loops to copy the values from those individual arrays to resulting array. Okay, so this is a very effective way of merging of two sorted arrays into a single array. Okay, now that we have implemented this, let's just try to call this function and validate if we are able to get the resulting array also in the ascending order fashion according to the values that we are giving. Now let's just say the values that I want to pass are, let's just say a1 equal to 1, 2, 10, 14. Let's just assume these are the values. Similarly, the second array that I want to pass is a2. Let's just say 1, 3, let's just say 9, let's just say 20. Okay, these are the values. Just to have much more clarity, let's try to run it on an array which has more length than array 1. Now ultimately we need to call this merge two sorted arrays, right? So first we need to initialize this merge two sorted arrays class. So for that merge two sorted arrays, okay, empty sa dot, okay, let's pass array 1 and array 2. Okay, in the end it will basically merge those two arrays into a single one and return the resulting array, right? Let's just store it into one variable result. To print it and validate, let's just write int I equal to 0, I less than result dot size I plus plus. Okay, here let's just do cout result of I, and after that let's just give some space so that we will be able to differentiate. And once this is done, outer for loop, let's just do end line. Of course we no need to, but it's just, I'm used to it and it's a good practice. That's the reason why I'm doing it. Okay, now according to this, if we merge these two sorted arrays into a single array, okay, according to the values that we are getting, the resulting array should also stay in the ascending order format. So the output should be 1, 1, 2, 3, 9, 10, 14, 20 and 21. So let's just execute this program and validate if that is the output that we are getting. So let's just do run code. Okay, if you observe the output here, 1, 1, 2, 3, 9, 10, 14, 20 and 21. So totally 5 plus 4, 9 elements should be there. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the 9 values are coming. Similarly, if at all if you want to make the list of size same as well, you can do the same thing, add couple of more values and execute it. So ideally, see, in the resulting array we've got 24 that we've added into the resulting, array 1 here. The same thing got reflected in the resulting array that got printed on the console as well. Okay, so that is the very effective way of merging of two sorted arrays, such that in the end, whatever the resulting array that got created will also remain in the sorted fashion. Remember that here we have solved the problem for merging of two sorted arrays which are in the ascending order. Okay, so that's it for merging of these two sorted arrays. In the next video, we will try to reuse this function as part of the merge sorting algorithm.